Hello, welcome back to my YouTube channel, and today we'll also be continuing with this retaining wall that I was explaining earlier. So now we'll be considering what is called the cantilever retaining wall. Under the cantilever retaining wall, you find out that this cantilever retaining wall is made up of reinforced concrete. Now what it means is that this concrete section for both of these types or shapes of retaining wall is reinforced iron rods are provided on the wall. This is can be called the wall or the stem, while this can be called the base. So reinforcements are provided within each section. So the same thing for this and also this. So when you look at this section now, you find out that you can have a section that has a uniform thickness, or you can have one that has a tapered thickness. So that is, the section increases gradually from the top down to the bottom, because sometimes you might not want to provide a bulky wall section, but you can decide to have a tapered section like this, because once we understand in physics that pressure increases with depth, so you increase it gradually in order to take care of the increased pressure that is coming upon the wall. So that is why this is an economic section, in that you don't need to provide a bulky uniform section, so you can actually gradually increase the section of your wall as you go down. The section of your stem or your wall as you gradually go down. So you also, the base, this outer section can be called a tool, while here can be called the heel. Now you can introduce an heel here in order to help you also cater for, or to help you act against the earth pressure that will be coming directly upon your section here. So this can also be used. So this is the weight of the whole section. So now, by providing an heel, you can provide what is called a passive earth pressure, PP, which can take care of which can has as an additional resistance against the active earth force. So this section, you can have an increased section, you can increase it, or you can reduce it depending on what you want the value of your passive earth pressure, passive pressure that will be resisting this to be. So anyone can decide to use. So if you find out that there is no need to provide an heel, you can actually remove the heel and leave it like this. So this heel can also be incorporated here, while this will be a straight section. So different designs have been, creative designs have been incorporated for cantilever retaining walls. So it is a very economic section, in that the volume of concrete that is required, compare this cantilever retaining wall, comparing it with the gravity retaining wall, you find that there is great reduction in the amount of concrete you will use in your construction, while your steel will help you to take care of for extra rigidity. So now you find out that it is designed as a reinforced concrete slab. So when we are carrying out our design, after you have analyzed the forces acting on it and you have gotten it, you will therefore design the number of reinforcement that will require to support this earth pressure coming upon this wall first, and after that you design that for the base. So you find out that this structure takes advantage of the weight of the soil resting on the base for extra rigidity. Now let me explain that. What does that mean is that you find out that there is section of this earth that is being retained is resting directly. Yes, this section here is resting directly on the wall. On the base. Yes, on the base here. You find out that what happens is that this provides extra rigidity for this retaining wall section. How does that mean? That means that this force will be acting downwards. This section of the earth will be acting directly downward. It will not be acting against the wall. So it produces extra weight to also support the weight of the retaining cross-sectional weight of the retaining wall. So that produces extra rigidity for it. So that means that the forces that will be resisting this active edge force is the weight of the soil beneath or on the base plus the weight of the retaining wall itself. So that produces extra form of rigidity. So it's a very economic and stable design if you can use a cantilever retaining wall. So now it can also help to retain material up to 7 meters height. Yes, you can actually retain materials for 7 meters height, but after that, if the material you are trying to retain is more than 7 meters, you need to be considering a counter fault retaining wall. So now what this means is that now 7 meters is like the height that you can get to when you are using cantilever retaining wall. So for this section, for 7 meters, you find out that you need to start worrying as your height begins to get higher. You need to start worrying about the stability of your wall, of this stem. So therefore, that is why this particular section is good for higher heights, up close to 7 meters, wherein you have to taper it so that the pressure can be adequately taken care of as you go down. So that is the reason why this is a better design for higher heights than this. So now let's go over to counterfault retaining wall. Now on the counterfault retaining wall is still the same thing like a cantilever retaining wall. The only difference is that a counterfault, like an extra stiffener. Now this is the elevation section. You find out that this is the counterfault. These two, as you go on, it is provided at intervals, at regular intervals. This can be at 2 meters, it can be at 3 meters, it can be at any design spacing that you actually want it to be. Now, so what it means is that as your wall gets higher, when you have a material that you have to retain above 7 meters in height, you need to start worrying about the deflection of this stem. So for you to provide extra stability for this stem, you need to provide what is called a counterfault. Now this counterfault acts as a stiffener such that by the time the active X fault is coming directly, is acting directly on the stem, there will be no overturning, because this force tends to overturn, that is, tends to push it, that it wants to overturn it, it wants to push it to lie on its face. So what it means is that this will provide extra stability by providing rigidity for it here. So this counterfault can either be rectangular counterfaults are provided to act as stiffeners for the wall and can be triangular or trapezoidal. So it can be a trapezoidal section or a triangular section. This is a triangular section. So now, if you have a retaining wall, let's say you have a cantilever that is like this. Now, you find out that this cantilever, it will get to a point you need to start worrying about deflection. So, but if you provide let's say you provide a steel or a steel rope that helps you. Now, by providing is another form of stability or strength for it, by tying it to this or to the support again, you find out that this section can carry, this cantilever section can carry more weight now than if you did not provide any form of stiffener. So that is the idea behind this counterfault that is provided in a counterfault retaining wall. So this is also made up of reinforced concrete, and these are the forms or the common types of retaining walls that we have. In our next class, we'll be analyzing forces that is coming on a cantilever retaining wall. We would also learn in the subsequent classes how to design a cantilever retaining wall, and to ensure that your section is safe for whatever it is you want to retain, whatever material it is that you want to retain. Thank you very much for coming to my class today, and I hope to see you more in my section. So don't fail to subscribe to this channel for more exciting videos. Thank you very much.